Hey everybody, this is 5.4 application. So just like we did for our last lesson was applications. So we're going to do the same thing but using point slope. So for all these problems, you'll either have the slope and a point that's not the y-intercept, or we'll be given 2 points. So for both of those, we're able to write an equation from point slope. All right, so we're just going to do a couple word problems, and then the rest will be for you. I think on your homework there's just 4 word problems, and that's it. So please, again, if you have questions, please let me know. I'd love to help you out. You just need to ask, and do your very best to try and understand this. I know these word problems sometimes are a little tricky, but it's probably the most realistic thing that would probably you'd use from this class is these word problems. So I'll try and go over this as best as I can, but make sure you ask questions if you need to. All right, so Jake read a book cover to cover in a single session, okay? At a rate of, okay, this is kind of a key word, is a rate of 55 pages per hour. Pages per hour. Okay, so that hopefully that sparks some information to you about like what is that. Okay, it says after 4 hours he has 385 pages left to read. All right, so that's our 2 information. 2 things that we need to know. Okay, we need to decide what those mean. Okay, so first it says identify the variables of the situation. What does X represent and what does Y represent? Okay, so remember always if we have X and we have our Y, okay, X will always be time if time is available. Okay, sometimes it's not, but most of the time it's time. So here, X represents your hours. Okay, it's kind of like, equations, this is like a function, okay? This is a function. You put something in and it gives you something out. You put in time and it gives you, for here, it gives you pages, okay? You can't change time. You can decide how fast you want to read. You can change how many pages you read, but you can't change time. So that's why X is always going to be your time if time is available. Okay. So Y represents pages. Pages left. All right. Okay. So first, let's find the slope. Which is the slope? Okay. Key again is kind of this per word. It's 55 pages per hour. So our slope here is going to be 55. Okay. Write an equation in point slope form. All right. Well, what is this other information that is given? Okay. This is our point. They give us a point. It's not the y-intercept. It's not the initial pages he has to read, but it gives us how many pages we have left after he reads 4 hours. So if we were to write it as an x comma y, hours comma pages, we would have our point is 4 comma 385. Okay, so for all these problems, we're either going to use a slope and a point. We need to figure out which one is the slope and which is the point. So now we can write our equation in point slope form. So again, we'll maybe label these. This is our m, this is going to be our x1 and our y1. Okay, again, slope, our point slope form is y minus y1 is equal to m times x minus x1. So we'd do y minus y1, which is 385, is equal to our slope, which is 55. Okay, let's talk about the slope. Is the slope going to be positive or negative? Is he adding more pages or is he finishing pages? okay? So it says that he reads 5 pages per hour, okay, and he's trying to finish the book. So this is going to be negative slope. It's going to start somewhere. This will be like the initial pages left, okay? And we're going to want to bring it down until he has no pages left, okay? So it'd be 0 pages. All right, so our slope here is going to be negative. So always, sometimes it's a little difficult to decide if the slope is positive or negative, okay? Just trying to think about at the end, if the end is going to be 0, if we're trying to finish something, then your slope is going to be whatever's going to make us bring it to 0. So here this would be a negative slope. If you had an equation or an example where like you started with a certain amount of money and then you got more money here, it would be a positive slope. So just kind of, sometimes you have to think about it a little carefully. All right, and then we do x minus x1, so that'd be minus 4. So we have our point slope. Now we want to switch it into slope intercept. So we did that already in our last lesson, okay? To do that, we would need to distribute, okay? We'd distribute the negative 55, so we'd end up getting y minus 385 is equal to, we'd distribute, we'd get negative 55x, and then we'd distribute it to the negative 4. So I'd probably just grab my calculator and I'd say, well, what is a negative 55 times a negative 4? And that gives me a positive 220. The last step you need to do is to add 385 to both sides to get it into slope-intercept form. So you'd get y is equal to negative 5x, and what does that give us? Plus 605. Okay, so we have our equation in point-slope form. We have it in slope-intercept form. All right, and now we want to find what is the y-intercept, and what does that represent? Okay, so just remember that the y-intercept is the y value for your slope-intercept. Sorry, let me say that one more time. The y-intercept is always going to be 0, b. Okay, and this is y equals mx plus b. So to find the y-intercept, it's going to be 0, 605. And what does that represent? Well, that's the total number of pages he has to read. Total, or the initial pages he has to read, maybe that. The initial pages of the book, or that he has to read, or something like that, okay? The book is 605 pages. Okay, and we want to find the x-intercept. Remember, if we want to find the x-intercept, we know that y is equal to 0, and we'll solve. So here we could use our slope-intercept form. We'd set it to 0, and we would just solve. So we could subtract 605, and then we could divide both sides by a negative 5. And would end up getting x is equal to, and I would just grab my calculator, divide it, and I get 121. Okay, so what does that represent? Okay, so our x-intercept is going to be 121, 0. Okay, so what does x represent? Remember, that is your sorry. Oh, my bad. Sorry. There's something fishy. It's way too long to read. Okay, and this is also a good thing. This is a good thing that I made this mistake, because we should always look at our values and say, does that make sense? Does it make sense that it would take him 121 hours to finish his book? okay, to have no pages left. So I forgot, I wrote it as a -5 instead of 55. Okay, so instead, let's fix that up. So -605 divided by 55, so that gives you 11 hours. And that is much more appropriate, I would imagine. Okay, so 11 hours. It took him 11 after 11 hours, he finished his book. Okay. All right, so we found our x-intercept, we found our y-intercept, and now we want to answer these two questions. If the rate of change remains the same, how many pages are left when Jake has read for 7 hours? So again, hours is our x's. Okay, our time is x's. So we're going to plug that into our equation, which was y is equal to, it was -55x, so we'll plug that in for 7, plus 605. You can just use your calculator, do -55 times 7 plus 605, and we end up getting y is equal to 220 pages. Okay, so he would have 220 pages left to read. Okay, that makes about sense, I think. Okay, we can always check that. How many hours would it take to have 77 pages left? So pages is our y. So we'd plug 77 into our equation. And then we would solve. So here we would need to subtract 100 or 605. So 11 minus 605. That gives us a -528 is equal to -55x. And then we divide both sides by a -55. We just divide that on our calculator. And we end up getting x is equal to 9.6 hours. Okay, so after 9.6 hours, he has 77 pages left to read. All right? All right, so I think the tricky thing here is deciding where do we put that in? Do we put those in for x or do we put that in for y? So that's why at the beginning we write down what x represents, and I think that kind of helps some people. All right, so here's one more example. If you are like super pro at this and you're done, you can just turn this off, okay? This one's a little different, so you may want to follow along. All right, actually you should follow along. This one is different, okay? So Mr. Mole left his burrow that lies below the ground and starts digging down at a constant rate, okay? So let's maybe kind of like draw a picture of what's going on, okay? So Mr. Mole, he's in his burrow under the ground, okay? Over time, he is going to dig deeper and deeper into the ground. So he starts digging down. After 5 minutes, okay, again, x will always be our time in minutes, okay? It says he was 39 inches below the ground. So here this would be, oops, I didn't do that super well, -39 feet, or centimeters below the ground, or inches, yes. And it says after 10 minutes, it says he is down, he's 54 inches below the ground, okay? And we're going to assume that the ground level is 0. If it's above in the air, that's positive. So he's down even deeper, okay? So what does x represent and what does y represent? So again, we're using time here, so we're going to say that x represents minutes and y represents inches. They want us to find the slope, okay? So for this example, they don't give us the slope. They don't give us a rate on how fast he digs. But he gives us 2 points, and we know what to do if we have 2 points. So we have 1 point they give us is 5, negative 39, and then the other is 10, negative 54. Okay, and we're going to want to figure out what the slope is, and it should give us a negative slope, so let's see what we get. So m is equal to, we'll label this as x1 and y1, x2 and y2. So we'll do negative 54 minus a negative 39 all over 10 minus 5. Okay, so we can just plug that into your calculator. This would give us a negative 15 all over 5, which is negative 3. Okay, so the slope is negative 3. He goes down 3 inches every minute. So we can do inches per minute. Okay, so that is our slope. And that makes sense that it's negative because it's going deeper and deeper. Now we want to write down our equation in point-slope form. So we have a point, we'll use the first point, and we'll use the slope. So we'd do y minus y1, that will end up giving us a positive 39, is equal to negative 3 times x minus x1. Okay, so now we have our equation, and we're going to switch it into slope-intercept by distributing first. So that gives us a negative 3x, and that would give us a positive 15. And then the last step would be to subtract 39 from both sides. So we'd get y is equal to negative 3 times x, minus 15 minus 39 gives us a negative 24. So his burrow where he started digging was, this would be our y-intercept. So our y-intercept would be 0, negative 24. So he's 2 feet below the ground, 24 inches below the ground. So that's what that represents, is his burrow is there, or where he first started digging, he was negative 24 inches in the ground, okay? When he started digging, he was 24 inches below the surface. Okay, something like that. Want to find the x-intercept? Well, you know what to do. We'd set y equal to 0 and we'd solve. So we'd do 0 is equal to, again, we just get that from here, negative 3x minus 24, and we would just solve for x. So we'd subtract 24. So 24 is equal to negative 3x, and then we'd divide both sides by negative 3. And we'd end up getting x is equal to negative 8. So our x-intercept would be negative 8, 0. And what does that represent? Does it make sense? So again, whenever we have negative time, it doesn't really make sense because we don't really know what happened before he started digging. So here, it wouldn't make sense. We wouldn't have anything that would like really represent this point, okay? But we can still come up with our x-intercept. All right, now we're going to use our equation to find these two things. Again, if they are giving us time, we're going to plug that in for x, and if they give us our y, our inches, that's going to give us our y. So we'll use our same equation, which was y equals negative 3 x, which here they say is 60 minutes. We'd want to see what happens after 60 minutes. And then, what was it? Minus 24. Okay, again, you can just put this into your calculator. So negative 3 times 60 minus 24. And we would get y is equal to negative 204. Okay? So this kind of makes sense, right? Hopefully. So he started this deep, and then every minute, since 60 minutes, and it takes he digs 3 inches down every minute. So we multiply that together to figure out how deep he dug, and then he already started at negative 24, so we get it even more deep. So he dug this 204 inches down. Okay, and that's pretty significant. If you divide that by 12, that's like 17 feet. And that's pretty impressive. Okay. All right, and then if we want to do the other, we'd plug that in for y. So 72 is equal to negative 3x minus 24, and we would solve. So we would add 24 to both sides. That would give us 96 is equal to negative 3x, and then we divide both sides by negative 3. So 96 divided by negative 3, that gives us x is equal to, oh, sorry, my bad. Okay, so there's a common mistake too. So he's this deep, all right? So this is for like our, if we had a graph, that would be, he'd be like even deeper. So this would be negative 72 when we kind of have to get that glean that from that information. So this would be a negative. So I kind of mixed that up. Okay, hopefully you caught that. That would be awesome. Okay, so we would still add 24. So 72, negative 72 plus 24. That gives us a negative 48. And then we divide both sides by negative 3. And that would give us 16. Okay, so it would take him, how many hours would it take him? Would be 16 hours. Okay, or 16. Here's what am I? Sorry, I feel like I'm doing something's messed up. Oh, that's about right. Yeah, I think that makes sense. Okay, so 16 minutes. Okay, so in 16 minutes, he can go 72. Because if we did 16 times 3, so I'm just kind of talking out loud. And then we had plus 24. Yep, so that works out. Sorry, I thought I did something wrong. Okay, okay, so to get that deep, it would take him 16 minutes. All right, so again, please shoot me an email if you have questions. We can do a Google Meet or something like that. I know the word problems is sometimes kind of the difficult part of math. Okay, so reach out, or you can come and stop after school or before school to get some help. All right, we'll see ya.